All right, here's our final video of the year, which is super exciting. So what we're going to talk about is what happens when we have a polynomial that bounces. So when we have that double root situation. So we're going to start by answering the same questions we answered in the last one. So the degree of our polynomial is going to be 4, which also means that our number of roots is going to be 4. Okay, and then we're going to look at our graph for the number of real roots. So the number of real roots is going to be right here. We have 1, but because it bounces, that technically means that there's 2 roots there. Okay, because it doesn't cross and it just bounces off the x-axis. So since there are 2 real roots and we need 4 roots total, that means that we're going to have 2 imaginary or complex roots. Okay, again, because we need to have those number of roots total give us back our number of roots. So our integer x-intercepts are going to be directly from that graph. So we have -1, and I like to write it twice just to kind of remind myself that we're going to have to do, it counts as 2. So that means our factors are going to be x plus 1, and we're going to have that twice. Okay, so we're going to do the same process as before. So the work for the remaining roots, we're going to take one of our roots and divide it into our original polynomial. So we're going to have x plus 1 is going to go into x to the 4th plus 2x squared plus, x cubed, not squared. Let's get rid of that. Okay. Plus 10x squared plus 18x plus 9. Okay, so for our first example here, we have x to the 4th in the top, which means we need to multiply x by x cubed, and then the bottom is also x cubed. But we want 2x cubed, so that means we need to add another x cubed, which gives us an x squared on top. Okay, so we have 1x squared. We want 10x squared, so that means we need to have 9x squared, which gives us a 9x and a 9x. Okay, and we want 18x's, so that means we need 9 more x's there, which gives us a 9 and a 9, which again makes us happy because we have no remainder. So then we have our second step here is to take our answer from the first division problem and divide it by our second root. So we're going to take x plus 1 again, and we're going to divide it into x cubed plus x squared plus 9x plus 9. Okay, so let's just switch colors here. So we have x cubed in our top box. X times x squared gives us x cubed, which goes on the bottom as well. Okay, and we actually want x squared, so that's going to be 0x squareds. So we have 0x and 0x. Okay, we want 9x's, so we need 9x here, which gives us a 9 on top and a 9 on the bottom. So no remainder, which is a good thing. Okay, and then we have our final step is to solve for our remaining roots. So we have x squared plus 9 equals 0. And for this one, I'm going to show you how to use the Pythagorean, or not the Pythagorean theorem, sorry, the quadratic formula. So you could have the option, since there are no x's, you could subtract your 9 square root. But just so we have an example of quadratic formula, I'm going to set that up for us. So we know our a is 1, our b is 0, and our c is 9. So to solve for our x, we're going to take the opposite of 0 is just 0. 0 squared minus 4 times 1 times 9, all over 2 times 1. So if we simplify that, we have 0 plus or minus the square root of 0 minus 36 over 2. So we have 0 plus or minus the square root of negative 36 divided by 2. Okay, and then our work with imaginary numbers comes into play now. So we know the square root of 36 can be written as the square root of -1 times the square root of 36. So the square root of 36 is 6. The square root of -1 is I. So this actually gives us plus or minus 6I divided by 2, which is positive or negative 3I. So our final answer is going to be just our roots listed out down here. So we know we have roots at -1, 0, and we have that twice. And then we have positive 3I and negative 3I.